Most of us think ice feels cold because, well, it just is cold. But that's too simple. It's a feeling, a reaction, a conversation between your skin and the ice itself. Imagine holding a cube in your hand. Instantly, a shiver runs through your nerves. You think, this is just cold. But science tells a more surprising story. Ice doesn't have a coldness stored inside it. It's not magic. It's physics, and it's tricking your senses. Contrast helps here. Place ice in your hand, and then a metal object at room temperature. Which feels colder? Often, the metal shocks you more. Why? Ice isn't always the sharpest sensation. It's your body losing heat to it. Cold is not a thing. It's the absence of heat. Your skin reacts to energy, leaving your body faster than it's comfortable with. Here's the hook. What you feel isn't the ice, it's your own energy being pulled away. Every molecule in the ice, every vibration of its lattice, is part of a microscopic tug-of-war with your skin. You don't just touch ice. You participate in a transfer of energy. And the intensity depends on more than just the temperature. It depends on the material, the surface, even how long you've held it. This section sets the stage for a bigger revelation. Most people never consider that what they think is cold is really a story about energy, motion, and perception. It challenges everyday assumptions. By questioning what seems obvious, we're about to explore the hidden science behind that shiver, the unseen dance between molecules, and why the truth is far more fascinating than the simple answer your instincts give you. Now that we understand cold is really about losing heat, let's dig deeper. Ice feels cold because it steals energy from your skin, molecule by molecule. Heat is a form of energy, and your body is constantly radiating it. When you touch ice, this flow of energy becomes intense. The faster the heat leaves, the colder it feels. This is why metal can feel even colder than ice. Even at the same temperature, it conducts heat more efficiently. Contrast framing. Ice is slow and deliberate. Metal is immediate. But both trigger the same story. Energy transfer. Every sensation of cold is a measurement of how quickly your energy escapes. Scientists call this conduction. The molecules in the ice vibrate slowly compared to the ones in your skin. When they collide, energy moves from the warmer skin to the colder ice. Your nerves detect this rapid energy loss and send a signal: cold, danger, heat leaving. Here's the hook. The perception of cold isn't absolute. Two people holding the same ice cube may experience different intensity. Factors like skin thickness, blood flow, and even expectation shape the sensation. Ice itself doesn't pull heat intentionally, it simply obeys physics. But your experience of it is subjective, shaped by biology and environment. This is where storytelling merges with science. We are part of an invisible conversation with the world, molecules moving, energy shifting, and our senses interpreting the results. Understanding this transforms a simple everyday feeling into a window into thermodynamics. Ice isn't cold, it's a mirror showing the flow of energy, the hidden forces at work in every interaction, the silent dance of molecules that your body perceives in the form of a shiver. We've explored why ice feels cold and how heat moves, but there's more to this than just a physical sensation. Ice is a master of contrast, shaping environments, ecosystems, and even human culture. Think glaciers slowly carving valleys or frozen rivers creating natural highways. The same energy transfer we felt in our fingers scales up to the planet, illustrating the invisible power of thermal dynamics. Contrast framing. Just as your skin loses heat to ice, the Earth loses heat to space. Ice is a storyteller of energy, showing how balance and imbalance drive change. Without understanding heat flow, we wouldn't appreciate phenomena like frost patterns forming on windows, or why winter sports rely on perfectly maintained ice. Ice teaches patience, showing how slow, consistent energy transfers shapes, landscapes over centuries. Here's the hook. The cold you feel is a microcosm of planetary processes. It's a tactile experience of thermodynamics at work. Engineers, architects, and scientists leverage this knowledge constantly. Refrigeration, air conditioning, even the design of winter clothing relies on the same principles your body experiences in seconds when touching an ice cube. By connecting human sensation to global effects, ice becomes a bridge between personal experience and universal laws. Storytelling in science doesn't have to be abstract. By observing, feeling, and reflecting on ice, we learn about energy, equilibrium, and the irreversible flow of heat concepts that echo across physics, chemistry, and biology. Each shiver, each icy touch is a reminder of molecular motion, energy gradients, and the subtle forces that govern life. The next time you hold an ice cube, remember, it isn't just cold. It's a teacher, a storyteller, revealing the hidden language of nature and the unseen exchanges of energy that make the world dynamic, fascinating, and alive.